See here friends, so this question is prove that root 2 is an irrational number. In this question, student face so many difficulties how they will prove root 2 is an irrational number. So today I will tell you how you will prove that root 2 is an irrational number. So see here, so as you know that root 2 is a rational number. So you can prove that by taking the decimal expansion of root 2 also. So but here you will not prove by using decimal expansion. Here you will prove root 2 is an irrational number as in statement form. Okay. So suppose that root 2 is an irrational. Suppose that if you want to prove that root 2 is an irrational number. So first take root 2 as rational number. So here first of all we will write down let root 2 is a rational number. So now see here, if root 2 is a rational number, then you can write that root 2 is can be represented in the form of p of b by q or a upon b. So write here, so root 2 is equal to a upon b. Okay. So now see here we have written a upon b. Now here in bracket we will write down a and b are co-prime number. Okay, a and b are co-prime number. So co-prime number means pair of prime number whose common factor is 1. Suppose that if we are taking 2 and 3, so common factor 2 and 3 both are prime number and their common factor is 1. Suppose that if you are taking 3 and 5, then their also common factor is 1. So a and b will be co-prime, means any prime number whose common factor will be 1. Okay. Now root 2 is equal to a can be written as also root 2b is equal to a. Okay, root 2b is equal to a. Now after that what you will do, you will square both sides. Squaring both sides. Okay, so for what we are squaring both sides? For removing the root term, root here, we are squaring both sides. Now we will check here whether the a and b are co-prime or not. Okay, so for checking we will square both sides. On squaring both sides, we will get 2b square is equal to a. Here we will get 2b square is equal to a square. Okay, 2b square is equal to a square. Now this can be written as b square is equal to a square upon 2. B square is equal to a square upon 2. Now here what we see that the 2 dividing a square. We can see that here 2 dividing a square. So this implies that 2 divides a square. And that implies 2 divides. So 2 divides a also. In this chapter you had learned the theorem if suppose that if any number a is there and any number b is there, if a divides b square, then a divides b also. Okay, on the basis of that theorem we are writing this. Okay, so it means 2 divides a also. Okay, now we will check whether 2 divides b also or not. So here what we will get, put a is equal to 2c square. 2c. A is equal to 2c. Here we will, for checking whether 2 divides b square or not, so we will check. We will put a is equal to 2c. So on putting a is equal to 2c, we will get 2b square is equal to 2c का whole square we will get. Now what will come? 2b square is equal to 4c square. Now see, 2 cancel the 4. What will come? B square is equal to 2c square. Now this can be written as b square upon 2 is equal to c square. Now this statement implies that 2 divides b square, so 2 divides b also. 2 divides b also. Okay. Now we can see that 2 divides a also, 2 divides b also. But here we have taken that the a and b are co-prime. Co-prime means common factor of a and b will be only 1. But here we are getting common factor of a and b 2. Here we get 2 is common factor of a and b. But a and b are co-prime. See here we have written a and b are co-prime, but we are getting 2 as common factor of a and b. It is not possible. If we are taking a and b are common co-prime, then we get one only common factor, not other number. But here we are getting 2 as common factor. So why this situation is arising? Why this situation is arising? This situation is arising because of our incorrect assumption. Okay. So here we will write down this situation is arising due to our incorrect assumption that root 2 is rational number. If root 2 is incorrect as an assumption, so therefore root 2 is an irrational number. Okay. So in this way we will prove that the root 2 is an irrational number. Okay. So you can see here at all the thing how you will proceed. Okay. So first of all you will take root 2 equal to a1b, and here you will write down a and b are co-prime number. After that you will write root 2b is equal to a. Now you will square both sides for removing the root here. So you will get 2b square is equal to a square. Now this can be written as b square is equal to a square upon 2. Now this implies that 2 divides a square. So we can conclude that the 2 divides a also. Now, okay, so what we get to 2 divides also. Now we will check whether 2 divides b also or not. So for checking we will put a is equal to 2c. Okay, a is equal to 2c. So on putting in place of a 2c, we will get 2b square is equal to 2c का whole square. Now what we will get? 2b square is equal to 4c square. We will cancel the 2 and 4 by 2. To cancel the 4 by 2, we will get b square is equal to c square. So here what we will get? B square upon 2 is equal to c square. Now what we now from here what we are getting? 2 divides b square. If 2 divides b square, then we can say that 2 divides b also. So here we get 2 is common factor of a and b. But a and b are co-prime. We have written C. Okay. So at the time a and b are co-prime, or there will be 2 as common factor of a and b. But this situation are arising. Okay. So this situation is arising due to our incorrect assumption. What if we have taken root through you will proceed and prove that root 2 is an irrational number. Okay, so there will be on the same basis you can prove root 3 also is an irrational number, root 5 is an irrational number, root 7 is an irrational number. Okay, so in place of 2 you will write only 3, or if you are proving root 5 as irrational number, then you will put 5. Okay, so I think you have got this. Okay, thank you class.